Hi, today we're going to do our Periodic Motion Lab 12A TikTok for physical science. Obviously, we're not at school, so we're going to have to modify our lab a little bit. So we're going to use this simulator, this Pendulum Simulator. I got this Pendulum Simulator from a website. It's called the PHET Simulations. The University of Colorado at Boulder actually sponsors this website, and it has lots of really cool simulations on there for physics, biology, math. So it's a great resource if you want to go there and just see what all they have. And it's a free resource, and I've used it for years, so I'm really thankful for it. So let's get back to the pendulum lab. Remember that when we're looking at pendulums, pendulums are something that has a periodic motion. Periodic motion means it goes back and forth. Simply, a pendulum is either a string or a bar with a mass on the bottom. Now, you have to pull it up and let it go, and then it swings back and forth. When it swings back and forth, that's one cycle of motion. So how long it takes for it to swing back and forth is what we call the period of the pendulum. So how long does it take to complete one cycle of motion? Okay, so in this lab, we're going to try to figure out what affects the period of the pendulum the most. Is it the length of the string? Is it the mass of the bob? Or is it the angle? We also call that the amplitude, the angle that we pull it back. Okay, so right now, we make a hypothesis. With you in masses, we're going to use 60 degrees is, so how far it is. Well, it's not time. Okay, let me pause our recording and figure out what's going on. Sorry about that. Hold on just a minute. Okay, I think we're back. Hopefully we're back. We had a little computer issue here. So we're back. Now we are going to test the mass. We're still testing the mass. And now we've moved it to 1 kilogram. So we're going to pull this back to 60, maybe, hopefully. There we go. Okay, it's just being slow for me today. All right, let's stop it. We'll start over. We're gonna make sure that it's at 60. Okay, 32, 40, 50, 60. Okay, we'll start a period timer and let it go. And it's going to give us a value of 1.5223. So 1.523. Okay, so let's go to 60. This time we got 1.511. All right. Okay, so now we're going to change our mass to 1.5 kilograms or 1,500 grams. We're going to restart our period timer, and we're going to bring it up to 60 and let it go. 60 and let it go. And we're going to start our period timer and see what we get for this. So we're going to record this one. Okay. Let's make it go here. Okay. So we hit 60. Okay, there we go. Now, again, this is our second trial, and we get 1.5223 yet again. Okay, are you seeing a pattern here? Hopefully you are. Let's see, 60. And we're going to and this time we're going to vary the length. If we can get to 1 kilogram. This time we're going to vary the length of the string. So first we're going to use 10 centimeters, which is all the way over to the end. We're going to use 10 centimeters, which is really small. And we're going to use our mass of 1. We're going to keep to bring it up. 60. 6792. It's very different from what we've already done. So, and this time we got points. And we're going to change it to a meter. Plus 60. See that? And we get 1.5223, which is what we would expect. Okay. 1.526. And start over and see. Okay, and we're almost done with this one. 1.523. To 1 meter or 1,000 centimeters. Okay, but we're going to drop it at 60 and we'll start our period timer. And now let's see how long it takes. We can start the period timer here. So this one, 2.129. It's harder to do with this mouse than it looks. Okay. All right. To a mass of 1. Choose the angle. And this time we're going to go 30, 60, 90. Okay, so at 30, let's see what we get. Okay, so we're going to move it to 30 and start our timer. And start our timer. So, okay, I'll work. Okay, 30 and start again. 4, 3, 2. Oops, I stopped it before. All right, there we go. Again, 4, 3, 2. And we've already taken it to 60 once before, so we're gonna do 3 more trials real quick. Actually, let's just do 1 more trial since we've already done this one and just see if it's consistent with the other trials that we had at this time. And 1, 5, 2, 2, 3, 7, 2, 3, 1, 2, 3, 7 years. And then we're gonna go up to 90 and we're gonna start at 90 and see what. So it needs 1, 6, 7, 4 for our first try, and 2 more, and then we get our data, okay. And see if our hypothesis was correct. Now, ideally, you would do this, if you were doing this in a laboratory, you would do many more trials and 3, but say we went into and up to 90 we go. Oops, 90. 90. Wow. There we go, 90. Okay. So at 1.73, which is what we got the first time. Okay, so now that we've done our trials, the next thing we're going to do is we are going to close that out and we are going to open up our spreadsheet. Okay, so we are going to open up our spreadsheet and hold on 1 second. There we go. Okay, so now we're going to open our spreadsheet and we're going to put our data into our spreadsheet. Ideally, you would be doing this yourself. Hold on 1 second. Okay, now we're going to look at our data. And here's our data table. I made an easy data table on Microsoft Excel. And so what we did, plugged in our values for each mass, each length and each angle. And then at the bottom, we have a table. This is really what we need, probably what we want to look at. This would be considered our raw data. Our raw data is everything that we wrote down and calculated. Then we average it. So each trial, we're going to get an average for each trial, for each mass, for each length, and for each angle. Then we're going to put our averages down here in the bottom, and then we're going to look at our averages and see which one affected the period the most. Okay, so as we look, the masses from 500 to 1,000 to 1,500, they were all around 1.5 seconds. We're going to skip over to angle real quick. In 30, 60, and 90 degrees, 30-degree angle was 1.4, 60, 1.5, and 90, 1.6. So if we were to do some other types of calculations, graphing, or making this into some sort of a line graph, then you would see that there's not a lot of difference between 1.4 seconds, 1.5 seconds, and 1.6 seconds. I mean, they're all under 2 seconds. Okay, so these are pretty close, but let's look at our length column. Notice at 10 centimeters, it's 0.6. Then at 50, it's 1.5. And then at 100, it's 2.15. So if you look at the numbers as they increase, this one increases from almost 0.7 to 1.5. That's a big jump. There's also a big jump from 1.5 to 2.15. So if we look at our data, what our data shows today, of course this is very limited data, but what it shows today is that the length will affect the period the most. Okay, so what was your hypothesis? Now it's time to look at your data. Since we looked at it, now you're going to either accept or reject your hypothesis based on the data. And my hypothesis today was that the angle would affect it the most, would affect the period of the pendulum the most. So today I would reject my hypothesis because obviously the angle did not affect it a lot, but the length would have affected it. So if you chose length, then good for you. Your hypothesis was supported today. All right, so the take-home message today is the length is what affects the period of a pendulum. All right, guys, hope you have a good afternoon, and I will see you next week.